I'll start by sharing my screen, which does not, in fact, have slides on it. There will be a few slides towards the end, but I tend to try to mostly just look at artifacts that you can then find yourself and play with yourself. You know, first, as a matter of, I don't know if I need to introduce myself, but you probably said something in the invite. But you know, I'm the current lead designer of C#. I have been for a number of years now. I can't even count anymore. Probably 7 or 8. Since whenever Anders Heilsberg didn't come back from us making TypeScript, and I did. Yeah, I run the C# language design team, and we can talk, if you want, we can talk about how we design C# and the process around it. I'm going to get to that a little bit. I wanted to just start by zooming in on sort of what is the sorry, question. So what's the status of C# out in the world? We can look at some of the artifacts that we use around building C# that you can participate in because it's all open source. And then I'm going to go in and actually talk about some of the things that we're planning for C#10. I do want to say right off the bat that this is going to be a fairly unique talk in that it's the first time I speak publicly. I have a talk publicly about C#10, but it's also the last time I will be speaking about C#10 without having a working prototype. So you won't be able to see the features in action. I literally expect to have the first prototype in my hands next week. So, but we'll still go into Visual Studio and we just play around anyway and write some code that won't compile, just to sort of create the vision of what's in store.
Ivan, can you please mute your microphone?
Yeah, I'm just finding a way to mute everyone because for some reason it's blocked on my computer. So if you bear with me 2 seconds and let me see if I can mute all.
Sorry.
Cool.
Yeah,
I think that's everyone muted by the looks of it.
If you want to ask questions, again, feel free to unmute and ask them or put them in chat, whichever is more comfortable for you. And really just stop me at any time. But jumping in, I do keep an eye on, not too much, but I do keep a little bit of an eye on the on various sort of metrics around programming languages. My managers make me. One of the ones that's interesting is the Stack Overflow survey that's once a year. There are all kinds of ways that it's probably skewed and not representative of the whole community, but it goes into a lot of detail. So it's a good read, and it's fairly consistent year over year. So that's good to follow. This is a survey of, or the survey result of the popularity of languages. So you see that it doesn't depend so much on whether you look at all respondents or professional developers. You see that C# among all languages, it's fairly high on this list. What is it, number 7? You take out the ones that aren't really programming languages like HTML, SQL, all the different shell languages, for some reason like batched together here, and C# is the number 4 most used language in the world. I think up from number 5 last year, but more due to others moving down than us moving up. We were fairly stable around a little less than a third of all developers using C#. So C# is definitely one of the most used programming languages on the planet, which is a little bit, only a little bit anxiety-inducing for us who are keeping it going. If you look at sentiments, they have the most loved, the most dreaded, and most wanted. When it comes to loved, I'm just happy to see C# in the top 10 here. This is where like little languages can play, because it's the percentage of people who are using the language that also like the language. And so it doesn't matter how big you are, globally speaking, it's how many of your users percentage-wise are happy that they're using you. And for some reason, Rust is like way out and above everyone else, but otherwise you see like a fairly flat edge there, and C# still fairly comfortably in the top 10. So we're happy that we're a language that many people use, but also that they like to use. It's not just because somebody told them you have to do this in C#. By and large, people choose to use C# because they want to as well. So, okay, we must be doing something right. In terms of the other emotions here, we're not in the top 10 of dreaded. We are somewhere down there, but fairly far down. And wanted means the percentage of people not using the language who would like to use the language. And Python is the big runaway hit here. A lot of people want to use Python. And I think that's great. The creator of Python just joined Microsoft, and I'm meeting with him every 3 weeks. Guido, and who only goes by his first name, Guido and Russell. So we have a whole little like language cabal at Microsoft. We have Anders with TypeScript and Herb Sutter with C++ and so on. But and there, all those languages are represented here. C# just squeaks in at a number 10 here. So there's still some people who would like to use C# who aren't currently, but it's not like this sort of indicates, along with like the long time that we have been in, that we have been around that position on the popularity scale, that the C# user base is fairly stable as compared to the whole developer population. It's slightly growing, but not like I mean, it's not a runaway hit. It's also not in any sort of decline, and that's been the case for now, like at least half a decade, probably more like a decade. So any thoughts on that? Questions?
Nothing from me. I have just noticed. I think John Skeets is actually in the call. I don't know if you guys know who that is, but that is a member of Programming Royalty who's joined us there. So I just thought I'd point that out.
I'm mostly here to nag Mads to do his issue in the ECMA standardization repo, really.
Well, look at the tab here. Up here, I was preparing to do that. You didn't have to come and nag me. No, I'm going to do it live. I'm going to fix my issue live. Actually, I'm not, but we'll go and look at it. But first things first. By the way, good to see you, John. The next thing I want to talk about is why do we think people generally like C# and use it a lot? Well, some of it has nothing to do with C# and has more to do with .NET. And some of it has to do with Microsoft, and some of it has to do with Azure. There are all kinds of reasons why people use C# that have nothing to do with C#. But that said, there is the fact that people tend to love C#. You know, there's something that we're doing right at the language level as well. And so 4 years ago, we decided to put words to, let me scroll up to the top here again. We decided to put words to what is actually the strategy? How do we think about the three main .NET programming languages that we are developing at Microsoft that has Microsoft teams working on them. So that's C#, VB, and F#, and that became the .NET language strategy, and it's kind of stood its time for those 4 years, talking about how we think about the different languages and how we think about their evolution, how we make decisions about them. And for C# specifically, which is like by far the language that is the .NET language that is used by most people, essentially the strategy is there's quite a lot of words here, but it's fairly easily summarized. Keep evolving, keep trying to make improvements that serve all or most of C# developers, not just specific domains, and keep strengthening and building on the community involvement. Those are sort of the three things that we wanted to do, and that I think it's fair to say that we've been good at doing since. So in terms of keep evolving, keep innovating in C#, that is that's a fateful decision, if you will. Like essentially with a programming language that has a lot of users, we have to respect backwards compatibility to a high degree. And that means whenever we put something into C#, we're making it bigger because we're not taking anything out to make room for it. It's just going to grow monotonically until the heat death of the universe or something. And so we have to be, of course, we have to be really judicious about what we put in because it's there forever. But at the same time, and that goes for all programming languages, but you can still have like you can still have a mentality about, should that pretty much stop us from adding anything? Like, should we show slow evolution down to a crawl, or should we evolve at a more rapid clip, trying to keep the language relevant and competitive? And we're choosing the latter. We want C# to be a language that you will want to use in your next project, not just that you are using for legacy reasons or because you already have a bunch of code in it. So that means that we want to address new domains in programming as they show up. It means that when there are good innovations within programming languages, we want to either be the ones making those innovations or stealing those innovations from whoever made them and find out how they can benefit C# users as well. And we're leaning into that fairly heavily, knowing that it means that the language will grow faster and will probably be somewhat harder to learn, and then try to mitigate those things instead of being scared away from having that evolution in the first place. And that works for many people. So for some people, it doesn't work so well. For those people, we have Visual Basic, where the strategy is different. The strategy is essentially to not add new features to Visual Basic, except evolve it so that it can keep being a first-class citizen in the .NET ecosystem and consume new features even when you can't declare them in Visual Basic. So it's kind of like these two different philosophies there, and F# is just a whole nother kettle of fish again. So that's sort of the thinking on language evolution. Are there any questions or thoughts here?
So Tony has just said, I don't know if you can see that, Mads, he said, you've been saying many times before, C# will never depreciate language features and you will keep growing it forever. But my question is, do you think you grow it too fast? Growth could happen at a more comfortable pace because more language features do essentially make a language harder to learn.
Well, that is the key dilemma, right? And we've sort of, you win on one end and you lose on another end whenever you sort of set that dial. And we set it more on the aggressive end of, no, we want to evolve it more. There are things we both want to embrace, new domains and new ideas for language features. We want to address user feedback when maybe something that was not so common before, but it is going to be more common now, when that is too cumbersome to do. And we know that we do that that comes at a cost. It's a cost that we're willing to pay, which is that the language becomes more complex. C# definitely tracks more to being a language for professional developers than, I mean, it's certainly a language that you can use, that you can learn as a novice or you can use as a non-professional developer. But if we have to make a choice, if there's real value in a new language feature, if it kind of pays for itself for its own complexity in value, then we will do it. Now we do various things and we're looking at more things to try to mitigate the consequences of this accumulation of features, if you will. There are certainly some features that are more advanced. There are certain features that, like unsafe code has always been in C#, and now there are more features around spans and refs and structs that are definitely targeted at an advanced low-level audience, and people not working in those areas can safely ignore those. So it's important for us to signal what sort of core C# versus maybe more specialized C# that's there, so that everyone else can get more efficient code on top of it. There's also, we're also looking at, are there, you know, trying to say what is sort of the core C# that you should learn first. There's some features that are a little long in the tooth where we put something better in. We still have to keep those features so code keeps compiling, but that maybe that's not how you want to do things today. So we're looking at trying to make that more, to take more of a stance there and give more guidance around. This is sort of the C# you would start out learning, or this is the modern C# that we will favor in tooling support, for instance, where refactorings will take you in that direction, templates will take you in that direction, and it may even be that you could sort of say, you sort of get suggestions to modernize your code, if you will, in many places. So that's something that we're looking at being more systematic about. More questions?
Just another question that 2 people have asked is there anything that you would like to take out of C#?
There are probably a few things, yes. That is a very common question, and my answer varies depending on the day, depending on what I was annoyed about the last time, because there are several. I think the one I will pick on today is the way that we did events and delegates all the way back in C#1. Essentially, delegates are they're the function type of .NET, right? They're how we do function types, but there's so much more. They're also a collection type because you can actually add any number of delegates together and get another delegate. And then when you invoke it, they all run. And events, which are a very sort of design pattern specific thing, were added to the language built on events or on delegates, and kind of those two were built for each other so that there's this like combined function and collection feature, strange kind of type in the language that works well with events. But of course, people use all kinds of other eventing models now. So events have kind of, they haven't really earned their spot in the language. They're a very respectable way of doing eventing, but one of many. Shouldn't have been in the language. And delegates shouldn't have been a collection type that was built to work with events. And we have all kinds of negative effects of that now that I wish we didn't. For instance, delegates are allocated object types. You can't have a function reference in high-level C# without doing some allocation, partly because of these things. So that's one. Anything else we want to highlight?
I think for now, yeah, that's questions. Yeah, I think that's all from the questions.
All right.
I'll go.
So quickly on the 2 other legs of the strategy, C# is being used for a remarkable variety of different purposes, not through the foresight of Microsoft for sure. It started out from our point of view really being a Windows app development language more than anything else. But people outside of Microsoft, in particular the folks around Mono, built an alternative implementation with the idea of taking C# to other platforms, to other form factors, and to other domains. Mono evolved into Unity, which is, you know, one of the biggest, if not the biggest, game development platform out there that's also based on a C# that Microsoft had nothing to do with, that just came about. And so through the foresight of others, C# became a language with an extreme variety in the number of different domains that it's being used for gain and pleasure. And we want to be really respectful of that and think about it as a general purpose language in all these scenarios, not just the ones that happen to benefit Microsoft at this point. And then the last bit is that, of course, C# is now open sourced, and we'll go and visit its language design GitHub site in a minute. And in many ways, we have opened up around the evolution of C# and the decision making in C#, the design of C# and the implementation in ways that have really benefited us all, in that we become much better language designers when we have a dialogue with the community that has to live with our choices. And that has made a fabulous difference. And that's sort of my, I'll take more questions here, but other than that, that's sort of my segue to the next tab in Edge here. So any more?
One of the questions here from Obina is the C# team working on features that would make developing .NET apps using C# MVU pattern more productive / pleasurable?
So MVU pattern, the model view update pattern, that's something we're looking at. There are some ways. So essentially, the MVU pattern requires you to create large trees that are logical representations of the next view, if you will. Like you're in a cycle where you build a tree representing what's being shown, and you build the next one and the next one. And just the sort of recursive creation of these trees is something that I'm sure we can do syntactic things to help with that. And I think some of the record features that we put in recently and are that we keep evolving on now also help with just the syntactic overhead of that. In particularly, we're putting more and more emphasis on making the use of object initializers a full-fledged alternative to using constructors. And that makes for really nice creation of large objects in place, right? Because it's much easier to read and write when you have when you can see the named nested properties instead of having to remember the order of constructor parameters. There are various ways that we are improving on that, and we do have that. We do have that in mind. We talked to the Maui team that is building our cross-platform UI framework. We talked to them quite a bit, and we'll keep, as they're working on maturing an MVU story there. We'll try to collaborate on making sure that that is a really first-class experience in C#. Great question, thanks.
I've got another question, but I think if you want to go on to what you're going on to, I'll ask it in the next break.
If it pertains to what we're talking about now, then absolutely, let's take it now.
So the question is, do you plan to collaborate with IoT platforms like Arduino or Platform.io with C# to support low-level coding?
There are definitely people at Microsoft working, actually, to sometimes collaborating with those teams. That's not something I'm involved in, so I can't really speak to it. It's a lot more that's sort of running .NET or quasi.NET, typically running .NET on that type of platform, one way or another. So it's definitely work going on there, but I can't really speak to details of it. I'm not really up on it.
Okay, I think that's it for questions for now. Thank you.
Cool. So leaving the strategy behind, let's go and actually look at where C# lives. This is C# home as a language. It's .NET C# Lang on GitHub. This is where this is a non-code GitHub site, if you will. The code in here are documents. This is where C# evolves. So all our artifacts related to the evolution of C#, they live in here. It's not like a display site where we put things out when we're done. This is where things evolve, where you see the sausage being made. So C# features, they sometimes, like a typical life cycle of a C# feature, successful one at least. Things start out unstructured in discussions. There may be some questions. people suggesting some loose ideas, and it all being discussed and turned back and forth. And at some point, somebody, and sometimes that's someone from Microsoft, sometimes it's folks from the community, somebody will say, I'm ready to make a proposal. And now a proposal will be made in the form of an issue. You can see most of these issues are proposals because we encourage everything else to go into discussions. And these are then fairly structured descriptions of what the feature would do, why we should have it, and so on. And that's, you can see the issue numbers here. There's a lot being proposed for C# over time. And the way we kind of manage the volume of things being proposed is that there's then a language design team, which consists of me and a bunch of other people that are the designers of C#, that are the group that collectively decides what goes into C#. And when we look through here, if we see something that we think warrants a discussion in that group, we will slap this label on it, proposal champion, and everything that's championed by one of the members of the design team now will at some point get triaged in a language design meeting, and we'll decide whether we'll keep it on our docket or whether that's not something we want to look at for now. And the way we do that is that we assign a milestone to it. So you can see this one is untriaged. It doesn't have a milestone assigned to it yet. These two here have been assigned to the milestone working set. So if you look at the milestones, there's some for past, just to track past features, what version of C# they actually made it into. There's the likely never milestone, which means, yeah, that doesn't seem like something we would ever do. There's the anytime milestone, which means this is small and we think it would be fine if it made it into the language, but honestly, we don't want to like put effort into it ourselves. But if anyone goes and builds it and submits a pull request to Roslyn, which is the implementation of the C# compiler and VB compiler, then we're likely to take it if it's of good quality and we can get it to where it fits in. Sure, we'll take it. So little features sometimes go in there. The backlog is, yeah, this might happen at some point, but we're not going to spend effort bringing it to the fore right now. So this is sort of like this is an intermediate. It's a dangerous place. It's a friend zone of language features, if you will. That's where you don't want to end up. So things sometimes spill from the backlog and then into the working set, this is where the active features live. These are the ones that we want to invest effort in, and that we think will eventually make it into a C# version. Although for many of them, it won't be the next one. So if you look in the working set, you can see here are some of the things that we actually expect to do at some point. And it's a grab bag of different things. Here's a big one, record structs. We'll be talking about that in a minute. So that's an example of a feature that is so far along that also in its implementation that this will make it into C#10. So this is that way you can go and see what's going on right now. Once things are this far along, we typically take the proposal and make it more permanent by putting it in the proposals folder here. So you can see here that previous versions have a folder. The ongoing things have their own markdown document here describing what's currently going on with them. So there should be one for record structs, and it's there. If you look at other parts of the code, I told you we have C# language design meetings. They're not broadcast, and we decided not to do that for the time being. But when the meeting concludes, Fred, one of the more junior members of the language design team, hasn't been there so long. He gets to be there. No, he's actually really great, but he gets to be there because he writes the design notes. That's what we tell him to whenever he gets too uppity. No, he writes really great design notes, and they describe in detail not what happened at the meeting, but what are the pros and cons and the technical details of what was discussed what was decided and why. So it's a good, we often go back to these to see why did we reject that feature, or why did we build it like that or make that decision. You can also, in here in the README, you can see the agendas coming out. Currently, we don't have any agendas, agenda items beyond tomorrow, where we'll be discussing record structs and some improvements to interpolator strings.
I've got a few questions for you here, Mads. So Duncan says, I've seen it written somewhere that C# is an OO first language that supports many FP concepts, and F# is a functional first language that supports many OO concepts. Many of the previous C# versions have introduced new features and concepts from the world of functional programming. And then his question is, what else can we expect to see added to C# from the FP world in the future, and to what extent will they be compatible with their existing equivalents in F#?
Well, that's a great question. It's a very good observation, and we make no secret of the fact that the primary hunting ground for stealing features into C# is certainly functional programming. It's because there's so many things that functional programming is good for when it comes to a modern distributed world, like a world in which the cloud exists. You know, the fundamental object-oriented co-location of code and data is cool for many things, like the fact that you combine the state of an object with the things that the object can do has been a very, and continues to be a very strong paradigm for programming certain things. But what you're seeing more and more is that that data and functionality are in fact in the world, they are separate, right? You collect data, you make it available somewhere for many different uses. And one of the things that functional programming is really good at is expressing the world like that, like data, the shapes of data types and so on are described separately from the functions that operate over them. And where virtual methods are sort of like the Swiss Army knife of object-oriented programming, of making sure that the logically same thing can be done differently depending on the shape of the concrete objects. The corresponding thing in functional programming is pattern matching, where a function can separately say, depending on the shape of those objects over there, do this, that, or those things, and express that in a very concise and elegant way. Which is why we added pattern matching to C# a couple of versions ago and have been evolving it ever since. So functional programming, in summary, gets a lot of things right. Link also came from inspiration from functional programming. We have to do quite a lot of work to adapt those functional programming concepts into the object-oriented world and make sure that they fit well together. So it's not, so you don't really have like an object-oriented and a functional language packed together, sort of uneasily cohabiting the same nominal programming language. We try to make them as integrated as possible. In this, we're quite inspired in philosophy, if not necessarily in detail, by the Scala programming language, where this is sort of its primary directive from day one, is to have a language that encompasses both object-oriented and functional programming seamlessly, and that's very inspiring to us. This does mean that sometimes when we adopt a functional feature that F# already has, we don't do it the same way as F# does it, because it has to fit in to a different context and be useful to developers that come at things with a different mindset and different experiences. So it's not always that when we pick up a functional language feature, that we make it work the same as it does in F#. And when that happens, like in a larger or smaller scale way, we talk to the F# team and we figure out ways to mitigate the differences so that the two languages interoperate as well as they can still. For instance, with tuples, in F#, tuples are reference types. Every tuple is allocated. In C#, that didn't really fit the scenarios for tuples that we were looking at. So we make tuples value types. And to mitigate, we made it so that C# can do the typical tuple operations, can do that on other kinds of types as well, including the F# tuples, like deconstruction, for instance. We made that a generalized feature, partly so that we could interrupt with the F# tuples nicely from the C# side. And on the F# side, they added the capability of tuples to be value types, the option for tuples to be value types instead of reference types. So that's a concrete example of where we bridged the gap, even though we decided to introduce it in the first place.
Okay, great. And then a follow-up question here from Craig is, if C# continually borrows features from F# or functional programming, isn't there a real danger that eventually C# will simply become a poor man's F#? Going in, Craig. And then i.e. a more bloated or verbose version of F#, given that C# is already a very large language, and since nothing gets removed, is it only going to get bigger?
Well, there's kind of there's a little contradiction in there, because the fact that C# is bigger than F#, which to some degree is probably true, that's partly because there are ways of doing things naturally in C# that you can't do in F# as naturally, right? C# has its own strengths existing, like the corner that it came out of with object-oriented programming. Those strengths persist, and even though you can do object-oriented programming in F#, it doesn't feel as natural, and it's not as core to the language. Like, they simply have different defaults. And for the same reason, C# will eventually, if it becomes any version of F#, it will certainly be a poor man's version, because it will never be as good as F# at writing clear, elegant, principled functional code. Like, it will never get there. That's not our purpose. There are many things in functional programming and many idioms in functional programming languages that we can be inspired from sometimes and adopt some of them and adapt them to, but the whole package with, with currying and those things, they're just things, the different ways that the type system, including its type inference, works, the different trade-offs where C# has subtyping as a core feature. In F#, subtyping is limited and more explicit because you want better type inference instead, and you can't have both to a full degree. There are all these different choices, and we can just never get there. And just using C# as a functional programming language is going to be an inferior experience to going to F#. If you want to do real functional programming on .NET, go to F# and do it with a, just do it with gusto. That's the right thing to do. It'll interrupt nicely with things built in C# and VB, and you really get the full benefit of being in a functional first world. We'll never get there.
Okay. And then last question for this little bit before you carry on. Guy has asked, or he said, globalization and internalization support in .NET has barely changed over the last 20 years. Our counterparts using Java use CLDR, which gets updated with depth and breadth every year. And then the question within that is, does Microsoft have plans to stop the globalization and localization support falling further behind?
That's a great question, and I don't have anything to tell you on it. I actually, I don't have many thoughts on that. Let's see. I want to get you an answer from someone who's more, who has more insights to our strategy here. So maybe. Maybe ping me and I can try to hook you up with someone. So everybody else will not get the answer then. I apologize for that, but I just don't have, I don't have strong insights here.
Okay, that's no problem. I can follow up with Guy, and we can, if he really wants the answer, we can follow up with you. That's not a problem.
Excellent. Yeah, let's do that.
For now, that's it. Thank you.
All right. So that's a little look around where we design C#. And of course, you can go and participate to the level that that you're comfortable with. It's going to be confusing if you go if you try to follow the day-to-day, but it's also fun, and a lot of people do it. So so one thing that's in here, if we go back up to the top of the code tree here, there's something called spec, which is a temporary thing. It's been there for several years now, but it's intended to be temporary. It's an unofficial specification of the C# language, and it's currently representing C# 6. Now, in the old days, there were too many C# language specifications. There was one that Microsoft wrote, and there was one that was the standardized C# that came out of the ECMA standardization organization. And they were very similar because they had some of the same origins, and they borrowed from each other and so on, but they were separate documents describing the same language. So we had too many specs and quite a complicated process to mediate between the two. Then the ECMA spec fell by the wayside for some years. Then the C#, the Microsoft language spec fell by the wayside for a few years, while ECMA started back up again. And there was sort of and John has been part of a lot of this journey, when we decided, okay, we actually do need to standardize C#. And we found that working on the C# standard as a great big Word document was very inefficient and didn't lend itself to collaboration. So recently, and I mean over the past couple of years, other than standardizing C# up to C# 5, or since doing that, the ECMA Standards Committee, involving John Skeet also here on the call, he's actually the convener for this group, we decided it's time to put in the effort to migrate the whole spec to Markdown as a source. And we've been working on that for some years now. And just a couple of weeks ago, we announced, Bill Wagner here, who's also part of the standardization committee, announced that the C# language standard and only official spec of C# is now an open source project. So here's the if you want to grab go and look at the announcement, you can find it here on the .NET blog. And here is the actual repo that now contains the C# language standard, along with tools for generating Word documents from it. And yeah, this is what happens. You can go and read the latest C# spec here, and watch the work, and moreover contribute to it if you find something that is off, or that is not well described, something that has not been spec'd yet because we're several versions behind, but you would like to contribute draft text to it. This can all happen here in a standard open source fashion, and this is where the official ECMA committee will now draw from to build the standardization for each of the versions that we choose to standardize. So let's go and click on standard here, and you can see the README is essentially, oh, it's not in here. Where is it? Didn't the README used to be the top level? Never mind.
Are you just looking for the talk, Mads? If you just scroll down. Yeah, if you just scroll down, it is in the top level README.
Oh, it was here. Yeah, I just didn't scroll far enough. Here's the table of contents. So you go and look about, you want to see something about identifiers. Here's the grammar now in Antler style instead of that weird Koenig and Ritchie grammar style that we had before. Everything in Markdown. Spec beautifully rendered. On its way to becoming C# 6 and C# 7. Those are the features that we're working on right now, and hopefully in a couple of years' time we've caught up to roughly where the actual C# that's released is. So if you have any interest in that, any questions about it, let me know right now.
Matt,
Yeah,
are you
yeah.
looking for contributors to the GitHub repo, or?
Always, yeah.
Sure.
It's as you can see, it's very new. I think unofficially it's been public for a month now. So contributors will always be great, and we still have to build a culture around how we do that here. But John has his eyes peeled, and everyone else on the committee. So we will incorporate any contributions we get, and we'll be happy to work with you. Just identify the most productive ways that you can contribute. That'd be awesome.
Thanks,
Yeah.
Matt.
Okay. So that became almost like the first hour of the talk, and we haven't looked at C# yet. So I don't want to send you off on break just yet, because I do want us to be in Visual Studio when we and I've done something there when we go to break. I don't want to talk about C# 10 specifically now. We got all the sort of general long-term high-level stuff out of the way. So here's some C# 9. I hope it works. I just updated, this is an internal build, and I just updated it 15 minutes before the talk started. So if anything breaks in Visual Studio, that's because I was dumb and did that. But here's sort of where we left off on some features in C# 9. So I'm happy to talk about some of those again, or explain. If you kind of don't hesitate to ask C# 9 questions here, and we'll reiterate what's going on, because it's still fairly new. It came out in November, as it RTM'd in November. So we now have records in C#. First of all, top level programs here. You don't have to have a main method to have your main program anymore. We have record declarations, which are really a kind of class declaration. A record is a class that has special has its default changed to being more value based and less reference based, if you will. So this particular record here has two properties. You can declare anything in a record that you can declare in a class. And in any class, including a record, you can now declare your properties with an init accessor instead of a set accessor. So an init accessor is an accessor that can only be run during creation of the object, including the object initializer. So I can initialize the object here using the initter of the property. You can write your own, like an ordinary property, like you can with other accessors, but I've used the auto properties here. But if I try to assign to first name or last name after the object was created, if I say Mads then dot first name, you can see how slow it is. It's the first time I'm running since I updated. If I want to change my first name to John because I'm a fan, then I get unfortunately I can't do that, John. There's only one. I can't do that because after that semicolon here, or after the end curly, it's no longer mutable. You can't set it after the object initializer is run. So that's C# 9 init only properties. And the record makes sure that the fact that it's declared as a record gives you a few things. It gives you the fact that it has a nice write line implementation that is based on writing out the values of the members. It has an equality implementation, including the object.equals and also equality operators like the not equals here. That is also based on the values of the members rather than just comparing references. And finally, it has support for non-destructive mutation, which means that I may not be able to mutate the object itself. You saw me being prevented from that just before, but I can create a new one that's like the old one with some things changed. So records in C# 9 enable with expressions that take an old object, an old record object, and gives you a new one that's a copy of the old one with whatever you specify here changed. Okay, so this actually happened nearly 26 years ago when I got married. I changed my last name to my wife's last name from Nielsen to Torgersen. So this represents now there's, instead of just changing the Mads object and destroying knowledge of the fact that I ever had another last name, this is more like how an administrative system would want to do it. There's a new record of me after the name change, but there's also one of me before the name change, so that both can be represented in the system. And this is often how you want to program with immutable programming. And if you want to do your MVU updates of trees as well, I'm sure you would also find a lot of use for with expressions there. Where you want that tree to be like the last one, except that child down there gets swizzled out with this change. So you can see how that generally is a good way to work in a non-mutating manner by nipping and cutting and tucking existing values. So that's where things stand in C#9. Now we want to take we think of this records values thing as sort of a first round. C# is going to come out every year now for the foreseeable future, and so we want to take stories like records and roll them out gradually and get feedback along the way and improve on. We have many ideas for how we can improve. Now we can find out which are the most important ones that most people are asking for as the next step, and also get correctives to what we think would be useful and how we think it would be useful. So based on the feedback we've gotten so far, one of the things people would really like is, yes, records are classes, but wouldn't it be, first of all, maybe you should be able to say explicitly that they're a class, and maybe you should, and so we're going to allow that. And part of the reason we're going to allow, so that means the same. It's just like I'm being explicit about the fact that this record is a class, but we're also going to allow you to say record struct. And that means, yes, it's a record, but underneath it's a struct instead of a class. We do essentially the same recordy things to structs as the C#9 records do to classes. And so we give you the way of distinguishing it in syntax. Of course, now the red squiggles start to come in because, as I said in the beginning, I don't have a prototype of this yet. I will have that prototype next week, hopefully just in time for recording the build demos, because build is only a month away. What does it mean to have a record struct? Well, in some ways, well, so it means some of the same things. Most structs also get a better toString that is based on the values inside, rather than just some gobbledygook. But when it comes to equality, structs already have value-based equality. In fact, the way we did the value equality in class records was based on how it's done in records. It was to match that to the largest extent possible. So, so records do not add additional value or additional equality semantics to structs, but because they already have it. But they do add explicit operators. They do add the equals and not equals operators, which structs don't have by default. Another thing about structs is that the basis for the with expression in class records is that the class has to somehow participate in specifying what it means to copy this object, so that the with expression can copy it and write something on top. And classes don't naturally have that. So records build some extra magic into the record classes to have that. But when it comes to structs, they can already copy themselves. That's how when you assign a struct, that's what happens. It gets copied. And again, we built the copying semantics of the class records on what structs already do. So with expression should already work. We don't need to do something extra to structs in order for with expressions to work on structs. And indeed, we're actually going to let with expressions work on every struct, not just on record structs. With expressions in C#10 will just work even if you just declare a normal struct. You can take it, have a copy, and have that copy mutated with a with expression, just like you can for record class. That's pretty nifty, huh? So if I do this, then this line won't work because the equality operators go away, and this won't print something nice, but the with expression will still work, even though this is no longer a record. While we're talking about the with expressions, there's one more place where we're going to let with expressions start working, and that's anonymous types. They have been in C# since C#3, since we added link. The fact that you can just say new and something that looks like an object initializer, and then you get a new object of an anonymous type. And in fact, when you think about it, anonymous types are really anonymous records, because for all time they have actually already had the value-based semantics. And so in a way, records are a generalization of anonymous. They're named anonymous types, if you will. And since anonymous types are also, they're immutable, we're going to also support with expressions on anonymous types. So once you have this declaration here, I can then do this with expression on this type as well. Even though it's not declared as a record, it is implicitly a record because it's an anonymous type. So you see how these concepts are spreading out to where people are saying, hey, why can't I do it here? Why can't I do it there? Where there's scenarios where people are asking for it on GitHub and other venues like here. This is where we get this kind of, okay, we can take it in this direction next, and then in this direction. And shipping major versions every year was at first very daunting to us and felt like scary. How can we ever wrap something up if it has to be done every year? How can we finish something properly? And the realization is, well, we probably shouldn't. We have to think ahead enough to not do something that we regret later, like use up syntax that we wanted to use for something else later, or get ourselves into a syntactic dead end with a feature that we wanted to evolve later. So we do have to think ahead, but we don't have to finish out the whole feature set. We can take the first step towards that potential future, and then let the interaction with the community tell us where to go next. And that is working better and better for us. Pattern matching today is a wonderful feature that started out small and has just grown based on that kind of feedback. And we're going to try to keep that same model for other things like the records and value-based programming we have here. We're going to keep trying to make using object initializers better, as we talked about before, make them more first class. And so the last thing I'm going to do before we go on break is to talk about one more way, unless we can see if there are questions now that are to this specific bit of C#. I'm seeing shaking of heads. Let's take one more feature then and then have a short break. So one thing that is a problem with records today, so let's actually just backtrack a bit to the code that actually was able to compile before, is that I could just not specify a first name and no one would complain. I would, just get the default value of the first name, which is null. That's not so cool. So now we have null Nilsson, and the next year will be null Torgersen. And there's no way I can say, well, you must specify a first name. We want to. That's not what I wanted to do there. We want to take that next step and make that possible somehow. And maybe I haven't been entirely honest with you here. I have not had the nullable feature enabled. Nullable enable. And if we do, we see some uncomfortable truths, which is that the first name and last name being non-nullable, returning non-nullable reference types here, are actually not null safe, right? Because the default constructor here does not make sure that they get initialized. And so I could create a person object, not initialize these guys, and have null in them, even though they're declared to be non-nullable. And that's what these warnings are telling me. Well, what could I do about that? Well, today I only have a few options. I could declare them nullable and say, okay, actually, it's okay to have a first name null. That feels unsatisfactory. Or, another option is I could initialize them with a field initializer, a property initializer, or something. But that's also it give you a last name by default. That's not really useful. That's just sort of hiding the problem that it was not initialized. You don't want this initializer to ever run, but how do you prevent that from happening? And the answer is required properties. We want to make it so that properties can be required. Public, let's see, how do I do this? Want you to be able to say that a property of field is required. And that means that essentially it means that it has to be provided in the object initializer. Going to make it so that a constructor, there's going to be a little knobs here so that some constructors can selectively choose to provide the values, but essentially this would make it so that not providing the first name or the last name would give an error. Like you get an error in your code, you have to provide first name and last name, or you can't create an instance of this type of object. Make sense? All right. I think this is a good time for a break.
I've a quick record-related question, if I may, Mads.
Oh yeah, let's go for that.
So I guess one of the tricky things with records that comes up is as soon as you sort of move away from the shorthand syntax and you start customizing it, and I'm thinking particularly around additional properties and things like collections, is that the value equality doesn't work unless you do some work yourself to customize things. And kind of the rhetoric around records is very much that they're bringing this value equality to the table. So you can sort of get caught out if you're not careful. And I've come up against a couple of situations where it would have been nice with generic types to constrain them to records. And I get, especially now that you've got structs coming for records, that doesn't really make sense when you think about how they work. But what would be really nice is if you could have some sort of constraint for value equality. Have you thought about that, or any conversations around that?
Not so much. I think that that might possibly be cool. Like we should talk about that. The thing about, some of the stuff that you bring up with value equality is it's a problem that is a little hard to address, because if you have let's say that you have a record on top, but then some of its members are collections. Well, what value equality on records does is it delegates to the equality of its members. It doesn't try to invent a new kind of equality for them. It just says whatever your equality is the one I'll use. So I'm structural and value based at my level, but whatever type you chose to put inside when you built me, that gets to decide the next level down on the equality. And collection types in .NET, by and large, do not have value equality. They do not compare their members. They just say, am I the same collection? No. Well, you're not equal. And it makes sense when they're mutable because they can change all the time. You might declare them equal, and by the time you're done with the test, they weren't after all, and so on. But and I can't remember what our immutable collections do.
They don't. Yeah, I think you have to do the heavy lifting there a lot as well.
Yeah, that's unfortunate.
So that's the pain point.
Yeah, so you have to do some tricks that are not entirely. Now it becomes a little unsavory. So I think that's a thing that we'll have to keep thinking about, is a way that we can push value equality deeper into the ecosystem. Or are there tricks that we can provide so that you can make your record, so your record can sort of enforce deep value equality, so that it can actually put its own equality on top of some members. So the things you can do today are things like have a wrapper on the collection, and then that wrapper implements value-based equality over the collection.
Yeah, and that's what we're doing now to work around it.
Right. Another thing you can do is override the object.equals implementation in the record. but then you have to implement equality yourself for all of its members, not just the ones that you want to change. Yeah, we talked about whether we should add some kind of like hook points for individual members and say, oh, by the way, I can specify a different equality for this particular member. But we couldn't find a good way of doing it, and we decided to wait and see how painful it was and whether good solutions came up. And we now know that it's somewhat painful. We don't yet know what to do about it. so we're part of that way.
Thanks.
Cool. Anything else on the record front?
Craig's just asked, why do we need the required keyword for records? Can we define a record like public record person, string first name, string last name, which achieves the same thing? No.
Oh, you can absolutely use constructors. That is essentially using a short form that records have for declaring a constructor. You can use constructors to require initialization stuff, and that works. So that's always worked in C#, even though we haven't had that short form for it. But declare a constructor with non-optional parameters and force people to call that, and everything's required, and that's good. The thing is, constructors have some downsides too, compared to object initializers. And sometimes the object initializer is the thing you want. And without sort of rehashing that discussion too much, this is really about trying to bring object initializers more on par with what you can do with traditional constructors, where traditional constructors are positional. It's all based on parameters in a certain order. Object initializers are nominal, and we can do different things with them. So, and the object initializers have a lot of benefits in terms of the maintainability of the class hierarchies you have, compared to when there are constructors calling each other and having to make sure that they all pass on the right things to their base constructors and so on. So, you're completely right. You can just use constructors, and none of this would be interesting to you. But if you want object initializers, by the way, this is not just for records. This is for classes in general. Like any property anywhere can be required. And you can then not call the constructor on this object without also giving it an object initializer, initializing these members.
Is there a reason why you have to specify if it's a non-nullable init property? Couldn't it be inferred, or there's probably a good reason for it? I just can't think of it.
Reason why you have to specify the requiredness in a non-nullable one? Yeah, I think that it's. I mean, it's mostly whether can infer. It's not always what you want. It's typically what it might typically be what we want, but not always that it's required. Could be that you have a constructor that initializes it, and then you don't want to require people to also have an object initializer for it.
I mean, in the case, it wouldn't compile here, right? With required out, it would say, oh, you can't have this property within it only, and non-nullable, and uninitialized. If you see what I'm saying.
Not quite. This would compile in C#10, yes. And it would not give me the nullability warning, because the required keyword tells the nullable analysis that somebody will initialize this with a non-null string before the object is released to the world.
But I mean, in C#9, if you took required out, it wouldn't compile. It would say, this doesn't make sense. So why can't required be inferred here? Or is it just aesthetically not nice?
It does compile. It only gives you a warning. And so we can't necessarily infer that you never want to have this combination of non-nullable and not required.
I'm confusing the compiler warning with the error. My bad.
Okay, yeah, but it's a great point. And we did think about linking the requiredness and the nullability more. But we think they're actually, as features, they're orthogonal. You can want all four combinations. They certainly affect each other in the nullability analysis, because if a property is required, we're not going to complain that you're not initializing it within the object. It is essentially seen as a way of initializing it. It's required on it. But other than that, they're best separate. Well, that's a conclusion we arrived at.
What will happen if you've got public required string ? Will that be like an illegal thing to write in C#?
No, that's perfect. We're not gonna. So it could be that null is a fine value, but we're not gonna put it in there for. We're not gonna. When I write this class, I'm not gonna let you just implicitly get the null. That's the default value. You have, if you want null, you have to specify it. So I can put that constraint on somebody creating the object. Yeah, you can put null, but it's up to you. And I'm not just going to silently leave it in there for you.
Right. So the required just means that you cannot omit it during the instantiation. Okay.
Exactly.
And so how would that play with reflection-based object creation, like during a JSON desynchronization?
That's a great question. The requiredness cannot. We don't expect it to be enforced in when you have reflection-based interaction with objects, and that's actually similar to other restrictions like read-only, which has been in the language all along. It's also not enforced through reflection. So if you want to circumvent a read-only, just use reflection, and things just work anyway. So while that might not be ideal, we decided this is very similar to read-only. There's no reason why it should have like some sort of stronger enforcement. Believe me, we looked at it very strongly, like are there ways that we can take this enforcement deeper into the runtime. We invented whole little generics-based meta languages in order to see if we could even make it break when things were separately compiled and so on. And we just went, that was a dead end, because we're not even keeping that amount of integrity when it comes to read-only, which is a core thing that's been in the language forever. So it's just like, this is, yeah, you can circumvent it. You can probably, it's going to be represented in the code somehow, so you can probably ask through reflection, is this property required? Either through a dedicated method, or there's going to be some attribute that we put on it. So I think there'll be a way that you can, if you want to, you can check for yourself, but we're not going to enforce it if you just try to jam your way through by creating an object and not initializing it.
Thanks.
Sorry, Matt. This record and the required keyword, can it be used in entity framework and entity core? Because this all looks like database as well.
Yeah, I can't give you the full story on that. I know that the EF team have looked at records and whether to special case them in various ways. And we talked to them about, we didn't actually intend for records to be recognizable in metadata. We just thought of them as a shorthand for writing a class that would have taken a lot more lines of code to write manually. But they were actually interested in recognizing them reflectively. And so we talked about the bad options they had, and I think they started relying on some of those. And we're going to put in a good option. It's not a language feature, but in terms of how we emit metadata, we're now going to introduce an official way that you can see whether a type is declared as a record for those purposes. But what exactly they do, I haven't tracked that lately. So yeah, I'll go and check that out.
Thank you.
So there's a question here from Neil that asks, would there be issues if records with required fields are used in object binding, as in API calls?
If it's reflection based and it creates those objects through reflection, then we won't be able to enforce it. If that's what you mean, I'm not sure I 100% understand the scenario, but the object binding, do you mean like data binding?
Neil, I'm here. Do you want to clarify?
So yes, I suppose it was a case of in object binding, I guess your classes are sort of constructed or populated when the call comes in. I was sort of wondering how the using required in that sort of scenario would affect things, because currently I think it would just sort of take on the default value, but if it's required, whether it would be the exceptions or but then again, if you're saying that there's reflection would sort of get around it, and maybe this is one of the things that I have to admit I'm not quite sure of the inner mechanics, but maybe that's the way around it. So
right. So the classical yes, yeah. So the classical forms of data binding are reflection based, and they'll just shove the values in there. They won't complain when the object is created, even if it had required members. Again, you can shove the values in. That happens even today, even if the members are read-only. Data binding will do lots of things, but if to the extent that it's reflection-based. Of course, there are new ways that people do some of these things, especially with source generators being around. Sometimes people are generating the equivalent strongly typed source code instead automatically and running that. That's starting to pick up as an alternative to using reflection. And at that point, we have the compiler involved, and the compiler will complain. And so there you can't circumvent in the same ways as you can with runtime reflection. So that's actually, whether you like that or not, that depends on your viewpoint. But if you want more enforcement, then and you go a route that is more source generation based, then you get the compiler in, and it will stop the madness and block you in the ways that the declarations ask you to.
Thank you very much.
I think questions now, yeah, if we just pause it there and go for a break, if you agree, Mads, and then
yeah.
I
know that we keep getting questions here. I do have some more things I want to show, and we have a good half hour left. If we say that we have a break until the half-hour mark, and then we take it through with the rest of the features.
Yeah.
Otherwise, I won't be able to keep my promise of getting through everything.
Fantastic. Yeah, and if anybody has questions that they would like answered that I've missed after the break, just put them in. But yeah, see you all at past. Thanks very much.
Thanks, Sydney. Thanks, Matt.
Thank you. Or more little features. This is not exhaustive of what's going into C# 10, but those are also some interesting little ones. And then I want to show a big feature that is not going into C# 10 as an RTM feature, but we're going to ship it as a prototype alongside with C# 10 because it's big enough that we want to get it out and try it out and get some feedback on it. Before we commit to the design of it. So, but I'll take that one at the end. So going back into our code here, I've reset it back to where it compiles again. I'm going to talk about the cliff for a bit. So when we first introduced auto properties, they looked like this. It's back in C# 3. And it took us forever to decide to introduce them because of the cliff. They represent a very common scenario, namely that you have a backing field and you're trivially assigning to and from it. But if you want to do just one tiny little extra bit, you fall off the cliff and you have to do everything manually, right? So if I wanted to do something in the setter that just trims the string of white space before it puts it in the backing field, well, you're doomed. You have to declare your own private field. You have to implement both the getter and the setter manually, and everything's back to C# 1.0. And even though we've generalized auto properties a little bit since then. So there's setter only properties, getter only properties, I should say. We don't have setter only ones. They're getter only properties now. We have initializers now. They weren't there in the beginning. But still, it's very easy to fall off the cliff. And we've been debating for years and years what to do about it. And we now think we've found our answer. There are many ways to skin the cat, but the way that we sort of landed on is that we want to give you access to the backing field of an auto property. So if I want to do, as I said, I do my initializer a little differently, I can give it a body that assigns to the backing field, but instead of just assigning value, it assigns something else, right? So we do that by allowing you access to the backing field through the keyword, the new keyword or contextual keyword field. Okay, so field means the backing field of this auto property that I'm in. I can say field equals value, and that will be the trivial implementation that's equivalent to what the auto property already does. But I could also say dot trim and do that. And then that just accesses the backing field that the auto property already has. The getter can still be auto implemented. But in fact, you could also implement the getter and still have a backing field, because the way the compiler knows that this is an auto, one way of thinking of it is the way it knows it's an auto property is that either some of the members aren't implemented or the field, the backing field is accessed with the name field. Either way, there's going to be a backing field generated for you. And another way of thinking of it is, in fact, all properties are auto properties. You can always say field in all properties, and there will be a backing field just waiting for you. And all properties have a backing field, except if you don't use it, we optimize it away. I mean, that's sort of a way to just rethink all properties in the world so that this fits in. There's a little bit of, I mean, John is probably itching to say, well, what if you already had something in scope called field? Won't that be a breaking change and so on? And yes, it would. And yes, we're going to do the ugly things that old languages have to do, where this only refers to the backing field if you don't have something else in scope called field. And if you do have something else in scope called field, well, too bad, you know. That's how we're thinking of it currently. Yeah, John is already it's already ready to confuse people. This is, you know, the gnarlies around it are similar to what we had to do around var, around nameof. When we add something new that looks like a keyword but has to work in the context where those words could already have been used to mean something else. For backwards compat, we'll do some complicated things, but morally speaking, things are only complicated if you run into those situations. Otherwise, it's really simple. That's just a new keyword called field. So that helps you not fall off the cliff. We did talk about another style of feature where you can declare variables inside of your property, inside of the curly. So I could have a backing field string ln declared in there, and then you could have your bodies refer to that. And that would be a way, like, let's say you wanted your backing field to have a different type for some reason than the property itself. Then that would be a way to still take those backing fields out of the scope of the whole class and accidentally assigning to them elsewhere. Like, you could still do that, but we're not likely to add that feature just yet. We want to see if people still ask for it once they have the this expansion here with the field access. So, and we're going to try to be smart about, I said that the backing field has the same type as the property. We're going to try to be smart about nullability here. So we will allow a backing field, we will infer that a backing field can be nullable if that's necessary for things to work out, even if the property itself is non-nullable. So we'll just check that the original value, default value of null will never come out, or something, you know, things like that. Or, you know, the properties required, whatever it takes. So we'll have a little wiggle room about nullability, but other than that, the backing field will be of the type, the same type as the property. Hopefully, I saw some happy faces, so hopefully that'll help people not fall off the cliff so much. There's a lot of band-aids have been. What do you call that? You don't call them band-aids in Britain. What do you call them?
A plaster.
Plaster. That's actually what we say in Danish as well.
Yeah.
Don't use brand names. Anyway, so that's one more feature. There's a couple of features that are really also, this is really shorthand features we're talking about. It's like shorter ways of saying something you could already say. And there's a few more of those that are kind of related. One is about usings. So what we have in C# today is that you have to put usings in every single file. Your usings are file scoped. And typically, you want the same usings available to you for any given project type or in your own project. So what you end up with is you have this set of usings on top. Some people like me get really annoyed that some of them get grayed out when they're not used. Like we want to go and do the refactoring that removes the unnecessary usings. And now you start getting diverging using lists in different files just because you're trying to clean them up, trying to not waste too much space on those. And but really, most of the time, you would just want to have the same names available to you in every single file of a project. That's very, very common. And so what you really would like instead is to just not have the usings repeated in every single file, but instead, you have, let's see, good morning. You have a usings.cs or something where all the usings that you need are centrally declared. Maybe they come in as part of the template. This file is just part of the template. It just gets put into your project when you create it. Of course, using it can't just be using because that is file scoped, but we could give you a version that is global using, and now global usings apply to every file in the project or in the compilation, if you will. And that way you can just never have to worry about usings in the individual files again if you don't want to. Or if you find yourself having adding the same using to many files, you can be like, let me just go and add it to my usings.cs file and as a global one, and I don't have to worry about that ever again. So on. Now, one of the questions we often get is, isn't this kind of global thing for the project, isn't that something that belongs in the project file, that like outside of C#? And we thought about that, but we would like this to also be able to evolve to to also be applicable to using aliases and so on. And now you get to like having to come up with a syntax for using aliases that is not C# but sits in a project file. In general, we've decided, for better or worse, that usings belong, the import of names belongs in C# source code. And so we're going to keep this in C# source code as well. It means that when you have very simple programs and people start learning and they're just typing their first statements and so on, it also means they don't have to worry about usings. They sit somewhere else. Or the interactive version of C# they're using just puts those usings into scope for them, or things like that. There's a mechanism for that. So that's boilerplate, sort of in the vertical sense of making your program files shorter from top to bottom. And there's a question: how does using work if you have multiple projects? Well, you have to have you can't have public usings. So they can't you can't have usings jumping from project to project. You have to have it declared inside of each project still. Now, one of the most painful things from a horizontal waste of space perspective is namespaces, right? Let's say that I wanted to declare this record here in its own class, like people often do, or in its own file. I have my usings there again. I just got rid of those. But typically I would have it in a namespace. I would say namespace my stuff, open curly, close curly, and let's move the close curly to the end there. And now when I pretty print here, adjust indentation, all of the rest of my code here now is indented 4 spaces to the right. And all the library code in the world is indented 4 spaces. Imagine if you took all those spaces, how many times to the moon and back could all those spaces go, right? That's a lot of screen real estate just because of namespaces. Now, namespaces are great and people use them a lot, but very, very rarely do they use more than one in one file. And very rarely do they have some stuff inside and some stuff outside of the namespace. So we decided, and we actually looked at public source code and our own source code and GitHub public coding in GitHub, and it's literally 99 point something of all files that have a namespace. They have just the one and everything declared inside, all the classes declared inside. So why not take that very, very common case and optimize it by allowing you to have a namespace directive like that, where the let's go and just delete some spaces here, where everything below is just in that namespace. Then we're like, okay, how does that? So that solves the common problem. Should we have rules for, like, what if you mix? Can you have more than one of these, or can you have one of these with a semicolon and then some with curlies inside? And do they nest, or do they start a new namespace? And then we just realized none of that is even legal. There's no reason to make any of that legal, because such a vast majority of source code just needs this. Like, so that's your horizontal space saver today. So you can, a couple of centimeters in each direction. You can start buying smaller monitors, or you can up the font a little bit as your eyes get older, like mine. So.
John has asked Mads, are using directives after the namespace declaration logically inside it, and using directives before the namespace declaration logically outside it?
Yes, that's what we're currently landing on. Yeah, we would be ruling out many more scenarios if we didn't allow using both before and after, because people do them both quite a bit. You can have inside of a namespace, you can have a using here that just applies inside of that namespace. So you can have using here that applies for the rest of the file, or you can have a using up here that applies for the rest of the file. You can have both. So.
Loads of people talking about how they can increase their font size and cancel orders for big screens there. So yeah, very popular.
Yeah, it's such a subtle difference, Mads, but yeah, that's really, really useful. I really like that.
Great. It's one of those, like, it's a really cheap feature to do, and it just helps a lot of people. It doesn't really add much to the complexity of the language. It makes the curly form sort of like a fallback form. Oh, I want to do something advanced and fancy, then I would use the curly namespaces. And coming all the way back to what we talked about in the beginning, this is the kind of thing that we would now include this in how you write modern C#, right? Write your programs top level, have your usings global in a single file, have your namespaces with semicolons. That's just how you write code. And yes, then there are these fallback syntaxes if there's something really advanced, or that's it's going to, and it should change how people write C# code by default. That's all I can. So would that create 2 namespaces? No, it would just be disallowed, because we couldn't agree on whether the second namespace should nest within the first, or whether it declares a new one on top. And so we just said, nobody does this, or 0.1% of developers might do this. So let's not even allow it. You get only one.
So to kind of get around that, we would create 2 files, right?
Create 2 files, or just fall back to the old syntax. Just use the curlies. It's fine. If you need because it reads much better. Like regardless of what decision we would take on the code in the that Devin posted there. Let me just imagine this is a separate file. Regardless of what position we take on it as a language design team, half of the world's going to be confused. Like we were split down the middle on whether that means this is nested or this starts a new namespace. We couldn't agree on it, and we all felt like our position was the obviously right answer. It was like, how can you even think it's nested? How can you even think it's not? When you just said we don't even need to solve that problem. The curlies are much better at removing any mental ambiguity around that. So let's just not force you to use those if you want to do those kinds of shenanigans.
Why not drop the namespace? Why not drop the namespace at all, like altogether, and just have it based on the assembly name and the folder structure? And if you want to change it, only then have it declared.
I think that's that's also a very interesting avenue. Like, can we take the namespace stuff all the way out of the files as well, just like we did with the usings, and put it somewhere central, or have it inferred, or have a mechanism for that? And that's definitely on the table, but it's not something we don't have concrete plans here yet. I suspect we'll be looking at some of that again in the C#11 timeframe.
And back to the global usings, why can you not just like have them auto open globally based on the package and project references, and then I don't even have to declare it in a global file, and I can only declare maybe a using if there is a conflict, and the compiler then maybe forces me to explicitly pick which one I want to open, and so I never have to do otherwise usings anymore.
Right. Some of that is just compat. We want the existing project types to not start putting new things in scope for you that they didn't before in existing projects. There are certainly usage scenarios, like we're also looking at, it should be possible, like C# is one of the few languages remaining in the world where you can't just run a .cs file. You have to compile it with something, or you can't just make a command that just compiles and runs it. And it always has to be in a project and that kind of stuff. So we're looking at simplifying that as well. And in those cases, it would be nice to just put some usings in scope for that one C# file that based on some project type predictions or something. And that's something actually we might get to in this release for those scenarios. In general, there's a lot of cruft from 20 years ago around how you build and run C#, and trying to clamp down on those and make those non-language things, or essentially non-language things, also more modern. That's definitely something we're looking at, doing a lot about.
And I think that the sort of different opinions that have come in just about such a allegedly simple kind of change there highlights how difficult it is to progress the language. And it's so difficult to make positive steps that make everybody happy and don't kind of damage legacy projects. So I think what you've done is really good, Mads. So
cool. Oh, thanks. All right. 9 more minutes and 2 more features. So let me see if I can. So the last 2, I'm not going to try to do in Visual Studio. Let's see. Let's move up here. One is about Lambdas. It's actually 3 features in one. We want to improve Lambdas a little bit in various ways. First of all, Lambda expressions today don't have meaning unless you convert them to a delegate type or an expression tree type. But some of them could have, like if you actually provide a type for the parameter, we could infer a delegate type for the whole Lambda. VB already does this, and we should just do that too. The plan is that if you have a Lambda that's not being converted to a type on its own, then we would try to find an action of func delegate, and if there's one that fits precisely, we will use that one. Otherwise, we'll just generate a delegate type for you in your assembly. But only for those cases where it otherwise would fail to get a type. So this one, so a couple of examples here. All the parameters are typed in both this and this case here. All the 0 parameters are typed. And we can infer the return type. But if we can't infer the return type, or if there's no type on the inputs, then it doesn't have a natural type, doesn't have a type on its own. And you can't do this var thing here. You have to specify a type. Say, what did you mean? What do you mean X? What X? We're also thinking to do that for method groups. So if you have methods or local functions or some named function that is not overloaded, then we can uniquely pick which signature it has, and from that we can try to come up with a good delegate type for it. Console or write line has multiple overloads, so we can't do it there. We don't know which of them you meant. So this will help sometimes when you're working with Lambdas. Attributes on Lambdas, you can put all kinds of things on Lambdas, like static. Why not be able to put attributes on them as well? And I should say that these Lambda features are ones that we've been eyeing for a while. The reason we're doing them now is that there's a great simplification effort going on in ASP.NET land, which involves letting people get away with writing much less code, like making a much simpler startup experience for ASP.NET. And if we do, and that involves some Lambdas, that if we do these features, then people can write even less code. So we want to help that scenario along, and that's why we're coordinating these features with them and doing them now. So if you put an attribute on a Lambda, the attribute is available for if you do some static analysis, but it will also be put on the method that we generate behind the scenes to implement the Lambda. So if you're trying to get at that through reflection, you can also see the attribute. So it's kind of good for all the things attributes are for, even if the attribute doesn't show up in the delegate type of the Lambda. Explicit return types. Why can't I say what I want in those cases where it's not obvious from a Lambda what its return type should be, or I want to be explicit about it? Why can't I just put a type in front like I can named functions? And we plan to let you do that. So this returns this here is a Lambda that returns a T, takes no parameters and returns a T. We're going to require for Lambdas to do this, we're going to require them to have their parameters in parentheses. Otherwise, this gets too ambiguous and strange. It's bad enough as it is. This one is really bad, but it actually will work. So that's why you see all my parameters in parens here. So that's just little Lambda improvements. Make the ASP.NET folks happy. Other people working with Lambdas, hopefully also a little bit happy. But with that, I am going to talk about that last big feature that we are building now that will be in the C#10, released in the C#10 compiler. You opt into the lang version preview, and then you get this extra feature. And that is, it's a big language feature. It requires runtime changes. It's the allowing interfaces to have static abstract members, maybe static virtual members as well. We'll skip that. So essentially, an interface today can specify instance members for its implementing classes and structs. So you have to have one of these properties on the instance. What if you could also specify static members and force implementing classes and structs to have certain static members? That would give us the ability to abstract over new things. And in particular, operators, which are static members. So one of the specific things that probably the primary specific thing we want to use this feature for is giving you the ability to have numeric abstraction, to abstract over things that have numeric properties and have operators and so on. So we are going to not just do this feature, but also built a library of interfaces representing various combinations of operators and other members that represent mathematical entities. That sort of, the iaddable here is sort of like a toy example of that. And then we're going to go to system.math. We're going to take all those functions that have overloads for all the primitive types like average and max and those, and we're going to put a generic overload there, and it's going to have a t that's constrained by whatever mathematical interface makes sense to implement that. And now, if you follow this example through, I've said things that implement iaddable, they need to have a static zero property that says what is the zero of this type, and they have a plus operator between two things of this type. They take the self type as a type parameter. That's sort of like that's like with I-equatable of t, right? It says, what am I equatable to? These say, what am I addable? What am I addable with? And now we can go and put these interfaces on our own primitive types, but you could also build your own types, matrices, whatever, and make them implement the same interfaces. So I now implement the iaddable interface. We implement the iaddable interface on system.int32. The plus is probably already there because the language provides it, and then you have to just provide an implementation for the zero. Now I can write a generic algorithm over t, where t is constrained by this interface. And inside of that generic algorithm, I can now reap the benefits of this feature by using the static members and including the zero property on t, and plus between t's now becomes available. And so if I go and call this, for instance, on an array of ints, then we're going to infer the type argument int. To add all, we see that int satisfies the iaddable of int constrained because of what it says up here. And now I can call this generic abstracted a numeric algorithm, which of course is not much of a numeric algorithm because it's a toy example. But you can imagine writing really involved generic code that now uses operators and does math in a nice looking way. So
yeah, that's something special.
What's that?
That's something special.
That is
ability. That's
yeah.
a superpower. Yeah.
That is really something where, you know, C# has really sucked at numeric abstraction, to be honest, and .NET hasn't really supported it for the same reason, and that's because we didn't have the ability to abstract over the kinds of operations that matter in math, and this is going to let us do that. So we're going to, at the same time, ship the runtime features to enable this, the compiler implementation of it, and the additions to the BCL, to the core libraries that has the numeric interfaces and utilizes them. And of course, anybody who builds on that, it can sort of be a way through, and they can, other people who do math on top can start taking advantage of this. So nothing I say today is secret. You can blog about whatever you like that I say today. So that's the last thing I want to show you. Again, not RTM in C#10, but you'll be able to use that whole package of those things. That's the plan anyway. We're actually, another feature that we are working on is enabling cross-cutting preview features that go across the stack of runtime libraries, language tooling, having a unified story for that. And this is our first sort of experiment of doing that. So you should be able to just flip one flag and then get both the library language and runtime prototype feature available so that people can go in to their everyday work environment and flip this on and play with it without having to install special things from here and there and get things mixed up. It's just a flag. So that's sort of us trying to think further ahead and do things now that can help the next version of C# beyond the one we're working on. And I think that's a nice one to end on.
Yeah, some really positive feedback to end on. One question there from Piers. will we see C#10 with .NET 6?
Yes. From here on and until we decide otherwise, there'll be a version of C#, a major version of C# with every version of .NET, which is every year in November. So you can add 4 to the .NET number and you get the C# number for the foreseeable future. Unfortunately, we weren't able to unify them. But somehow they're not keen on renaming .NET 6 to .NET 10, and we can't take it backwards, so too bad.
Stefan has asked, will C#10 also feature argument null checks via 1 or 2 exclamations? And if I remember preview, oh, sorry, my question's just disappeared. If I remember a previous language preview session correctly.
That is, as far as I understand, that's still the plan. Yeah, we do have an implementation of this. The idea is that you can say, let's just go somewhere random here, that you can say public void m string s bang bang, or, you know, people who watched movies many years ago, they could call it chitty chitty bang bang. And that, what that will do is it will generate into the beginning of the method body a check for null and on the parameter, and throw an argument null exception with the right with the name of the parameter if that thing was null. So it's sort of like a stronger version of nullable that doesn't just trust you but verifies. It's the Stalin version here. So that's still I believe that's still on track. It's a while since I get in doubt here just because it's a while since I saw anything about it, but I think that's just because it's already in the box. But if I'm mistaken, you'll just have to show up and kill me.
One last question that I'll ask then is from Tony. He says, will C#11 allow us to create custom operators and currying of functions?
No. I think, I mean, F#, one of the F# allows you the ability to create your own operators. Just throw some symbols together out of a, you know, n symbols out of some fixed set of glyphs on the keyboard, and you can declare your own operators. And that is a really cool and useful and general feature. In C#, we haven't even begun to scratch the surface on thinking about whether that's even possible. So operators other than the ones that are already in the spec, or in particular the ability to concoct your own in sort of open-ended set, we're not even close to thinking about what that would look like. I think we'll see if, I think it's one of those things where depending on where the numeric scenarios go, once we've enabled this feature I showed you, there may or may not start being pressure for something like that. And then we'll have to think about it. But for now, this is sort of like the crawl before the walk and run. So it might come back and actually be plausible, but not in C#11. C#11 is only a year and a half away. And currying of functions, well, it's not going to be built into the language, but you can curry functions today. You know, I mean, you can return a delegate that returns a delegate that returns a delegate, and they're curried. But it's a little painful, I admit. It's probably not, I don't think that's one of those things that is just too much tied in with a functional paradigm. It would be too clunky and not useful enough in C# as it looks today. Maybe, you know, in 5 years, you will get the last laugh on that. We'll see.
Okay, we have a question here. I think it relates to right at the start about the popularity of languages. So why does Go language have so much popularity relative to C#? That's quite an open question, that, but if you want to have a crack at it.
And in terms of developer love, it's a good question. I think, I mean, obviously I'm biased. I'm tempted to say because people are stupid. No, I think Go appeals to people in certain ways. It insists on being a very simple language. You know, they are just now talking about evolving it for the first time and adding generics to it. People love that it is very simple. For certain scenarios, that means there are not all these different ways of doing things. There are not all these mechanisms to choose from. It's just simple code like we wrote in the 80s, you know. And that has an appeal just in that simplicity. But I think it also limits the language in ways that seem to have meant that the explosive growth that it had in the beginning kind of seems to be limited by the Docker container Kubernetes environment that it's been growing up in initially. It doesn't seem to have as much crossover pickup. So people like using it there. It fits well with the platforms they built on top of because they were built with Go, and people seem to have a great time there. And a lot of people get intrigued and charmed by Go at first, and then I hear a lot of those later say, you know what? In the end, I got really tired of having to write everything from scratch every time. Like there are too many ways I can't abstract, and too many things I have to do again and again. Too many design things that come back to hurt them. So I don't know. That's my take on Go right now.
Yeah, I think quite a few people have shared a similar opinion there in the chat. So I think I'm conscious that we've had you for a long time now, Mads. So just thank you very much for all of your time. And thank you everyone that's been here participating as well. I think that has really added to this talk is your questions. Do you want to say anything in closing, Mads, at all?
Well, that will be a big thank you as well. These were great questions. This was just what I hoped for. Like we meandered off on all kinds of paths based on your questions, and that were really insightful. We got to some deep things, and I still got to show what I came with, and and got a lot of feedback on that too. So thank you so much. Like I always walk away from these with new thoughts bubbling in the back of my mind, and it's been great. Thank you very much. One day, I will actually be in the UK when we do this. But,
great.
We'll see you then.
Yeah.
Absolutely.
Thank you.
Thank you, Mads. It's been really amazing, and obviously we have recorded the talk as well, so that will come out towards the end of the week. So Mads, feel free to share it, and anyone who wants to listen again and see it all in replay, that'll be there for you as well. But yeah, Mads, it's been a brilliant session, and as Sydney said, thanks to everyone who came as well.
Thank you.
Thanks, Mads. Thanks, IO.
Thank you.
Cheers, guys.
Thank you.
Bye.
Tack Mads.
Thank
Det var
you.
skide godt.
Thanks, everyone.